Hi everyone. What I want to talk about today is backing up using DD, which is popular in Linux because it's it's easy to use and does a great job. In this case, I'm going to talk about the special case of backing up a Raspberry Pi micro SD card to try and obtain a little bit more efficient backup. If you look at Pi, particularly in the special purpose projects, they can often only use a small amount of disk space, especially if operating under the light version of the Pi OS. With small capacity micro SDs becoming less and less available, you're stuck having to back up a large micro SD card with a lot of empty space. Also, an issue is that not all manufacturers' micro SD cards have exactly the same capacity. For example, a 16 gig card from one brand might be smaller than a 16 gig card from another brand. So if you're restoring a backup image created from one 16 gig card to a slightly smaller 16 gig card, you'll see an error as the partition table will be wrong sized. So a solution I'm offering today is to first shrink the primary volume on the Pi micro SD, use fdisk to show the number of sectors in a resulting shrunk partition, back up using DD with a block count set to cover only the partition, not the entire micro SD. When you're done, you want to grow the partition back to its original size. And then after the image is created, you should really flash a new micro SD card and test the card in your Pi to see if the backup was successful. Okay, so the command I'm going to use is shown below. I'm capturing the card from an SD card slot in my laptop. And if you go over and you look at the count has it equals as nothing right now, that'll be determined after I shrink the card. And so we'll insert that into the command and then run the DD backup. So let's first look at a dump, an fdisk dump of the micro SD card. You can see at the bottom that the end sector is 155.23.839. After we've shrunk the card, that number will be reduced, and that'll be used in the command to image the SD card. So we'll zoom out here, and let's get into gparted. Okay. So before we shrink, I really want to make a point about how gparted presents the used information on a partition. I've seen it different and we'll show it in this demonstration, how the reported used portion of the partition can be different when you go back and forth between the mounted and the unmounted case. And I've seen it go in either direction. The unmounted case can be larger than the mounted case and vice versa. The unmounted case can be smaller than the mounted case. So what you want to do is go back and forth between the two cases and choose the larger of the two sizes to make sure you're including all the file space on the SD card and not shrinking it too small. So let's go ahead and unmount the partition, and in order to do the backup you need to have all the partitions unmounted anyway. So let's unmount it. So look at how this has grown. It was about 2.1 gig prior in the mounted case, and now it's 3.2 gig in the unmounted case. So again, you want to shrink it to the larger of the two cases. Okay. All right, so I'm going to shrink it, and we'll shrink it to a size that's going to end up saving about 4 gig when we do the backup using DD, because we won't be backing up the entire micro SD. Okay, so now we'll just look at the resulting partition, and you can see that it's shrunk to about half, with the end sector being 722.32.95. All right, so let's copy that, as we will put it into our command. Okay, and I'm actually going to make the count a little bit larger, because I want to make sure that I get a few more sectors in there, so I'm not cutting off the partition. Okay, so we'll run the command. All right, so now the image creation is done, and the first thing we want to do is just get back into gparted and grow the partition. And what we've done here is we actually haven't changed any data on the SD card. All we've done is written a new partition table into the SD card to show the lower amount of partition space. So now when we grow it back to the original size, then since we haven't actually manipulated any data on the card, we shouldn't have lost any data in this process. So if it turns out that your image's size is incorrect, you won't be hurting the original source card that you did the copy from. And like I said, you should always take the resultant image and flash it to a new card and do thorough testing to make sure the image is good, so you have a good backup. Okay, so now what I'm going to do is you can actually go ahead and mount the image, and it'll look like the as if you're viewing the SD card. So you can see I have my files in the typical Linux arrangement. Look at my home directory, because in this case I'm backing up an application which is a security camera that I've done, and it's got the files under the program, and I'm using motion in this case. So we've had a successful backup here, and you've done it saving a lot of space, and then when you go write it to another card, you're not having to write a large image to your other SD card, which will take much more time, particularly if you're using like a 32 gig or 64 gig SD card. It seems like it takes forever in order for the image to be written. So thanks a lot for watching. Have a great day.